Hi, I'm John Santiago, and I'll be talking about amplitude modulation. If you have questions on this demo using the Matlab Simulink program, contact me at http://www.freedomuniversity.tv or at the following email at john@eliteworks.com. What I'll be talking about today is amplitude modulation. Amplitude modulation in this demo will be using Simulink, which can be found in Matlab. So what I have here is a message with a bias, and this bias is important because that distinguishes between two types of amplitude modulation. One is called double sideband large carrier and double sideband suppressed carrier. The one with a constant is called double sideband large carrier in our message. Okay? So what I have here are these two functions added together, which forms our message. The message is then multiplied by this carrier using this product function or block. And then with this block we have at the output a scope where we can see what the output of this product block is. We also have a scope seeing what the message is, and a carrier scope to see what the output of the carrier looks like. Alright, so we'll run this demo. Taking a look at our message, it's 1 Hertz with an amplitude of 1, with a frequency of 1. We have a carrier at 20, so let's take a look at the output of that. So that's the output of the carrier, and when we multiply these two functions we get our amplitude modulated signal. Notice the carrier is being modulated in terms of the amplitude by the message. So we take a certain attribute of the carrier, which could be the amplitude, the frequency, and the phase, but in this case what we're doing is modulating the amplitude of the carrier, and this is what we're doing right here. This is called double sideband large carrier. To see what double sideband suppressed carrier looks like, we zero out the constant. But first note that the envelope of the message can be found right here. Okay, so when I zero out the carrier, we're going to see where the envelope is for the double sideband suppressed carrier without any constant in our message. So let's run the simulation again, and we see that our message is still here, but this time the envelope of our message is right here. Okay, so these are the two types of double sideband carriers for amplitude modulation. So here this is double sideband suppressed carrier because we don't have a constant in our message. Alright, a constant value. Now we're adding back our message again, our carrier, our constant too. We'll run the amplitude and we get our double sideband large carrier. Now let's change our message to a square wave and run the simulation again. And we see here's our square wave, and our carrier is being modulated by this square wave message, and we see that is found here. Alright, one more change in the function. We'll change it to a sawtooth this time. Okay, run the simulation. This is our sawtooth, same frequency as is in the square wave and the sine wave. Our carrier remains the same, and here we have the envelope again. Now if I suppress the carrier without a constant, I get a different waveform suppressing our carrier, and there we have it. There's our message right here and here. Since our message looks like this, up, down, then our message can be found right here. In our next video, I'm going to show how we can recover the original message getting back based on this. This amplitude modulated signal, if I put back into the carrier, run the thing again, this amplitude modulation large carrier is used in your AM radios, okay, which ranges from a frequency of 530 kilohertz to 1600 kilohertz. That's it for the demonstration for amplitude modulation.